Hey guys, welcome back to another Math with Max. Again, my dogs are asleep, so I'm very sorry if you enjoy watching them, but they are both cozied up on the couch. Max literally has like two pillows right underneath his head right here, so his head, he looks real cute. Like, And then Rocky's all asleep on this side though. So Max is on this couch and Rocky's on that couch, and they are relaxing. They had a long day outside, so sorry about that. All right, first things first, talking about polygons. More specifically, we're talking about triangles today, okay? We're talking about classifying some triangles. So what I want you to do is get out your journal, turn to your table of contents. Yesterday, we talked about a hierarchy of quadrilaterals. So we were showing how it would look if I put it onto a graphic organizer, okay? This is gonna be a different kind of graphic organizer. By the way, for anybody that's new to, or if you're in a different class, I'm already moved on to my second page of table of contents. So go ahead and put on there. I can't see very well. There we go. Number 44, classifying triangles. Okay. Then go ahead and go label your page 45 in your actual journal. So again, this was yesterday. Yours might look a little bit different if you're in Miss Rodriguez's math class. That's okay. It's the same thing. And then we're going to turn our page, and I want you to draw this. Okay, hopefully you can see that. This is going to say classifying quadrilaterals. On the left side should be acute, right, and obtuse. And then at the top, we're going to do scalene, isosceles, and equilateral. Just like that. Okay, so pause that and copy that all down. So this is a lot different than the graphic organizer that we did, or hierarchy that we did yesterday. This is actually going to be like a kind of like a check-off list to kind of figure out, okay, well, what goes with what. So when we were putting down our vocabulary card, we talked about how you can classify. The word classify means to name. You can name triangles or classify triangles based on their based on their sides, how their sides are, like the length of their sides, or by the measure of their angles. So you can have a right angle, you can have an acute angle, or you can have an obtuse angle, right? I know y'all have learned that with the arm things back in the day, right? So we're going to put off check marks as to what each, where they would be, if they're acute and scalene, or if they're right and isosceles, or whatever they may be. Okay, so we're going to start right here. So right here, we would be acute and scalene, right? Scalene. Okay, so we need to ask ourselves, can we have an acute triangle that is also scalene? Okay, so if I were to draw out a triangle, and we'll start with acute, okay? An acute triangle meaning that all my angles are less than 90 degrees. Okay, so an acute triangle maybe something like that, okay? All my angles are less than 90 degrees. So I'm just gonna do like my little angle symbol that I've been doing, okay? All these angles are the same. They're less than 90 degrees. Well, they're not exactly the same, but they're less than 90 degrees. Now, can it be scalene where none of the sides are equal to each other? Because that's what scalene means. None of your sides are equal to each other. It looks like I could. Like maybe, for example, this one could be 2, this one could be 3, and this one could be 4. Okay, so it is possible to have an acute scalene triangle. So on my chart, right here where scalene and acute meet, I'm going to put a check mark because I can have a triangle that is acute and scalene. Okay, so moving on. I'm still with the acute. I'm going to think about, can I have an acute isosceles? Okay, an acute isosceles. So what does it mean to be isosceles? Two sides are equal to each other. Okay, so for example, this one's 3, this one's 3, and this one is 2. Okay. Are all my angles acute? Yes, they are. They're all less than 90. Two sides are the same. That's what makes it isosceles. So can this be an isosceles acute triangle? Yes, it can. So right here, I'm going to put another check mark. Bloop, bloop. Okay, so again, this is showing me that I can have an acute and scalene. That's why the check mark is here. And then I'm showing that I can have an acute isosceles. That's why I have a check mark there. Okay, the next one is asking, can I have an acute equilateral? Okay, an acute equilateral. Let's see. I think I might. An acute equilateral. Can I have an acute equilateral? Yeah. seems like I can, right? All three angles are the same, and then all my sides are the same. So equilateral sides and then equilateral angles. So yeah, I'm gonna put a check mark, bloop, bloop, right there, okay? Now, moving on to right triangles. Okay, so all of these are gonna go with the right scalene, right isosceles, and then right equilateral. Now, not all of them are gonna be check marks. There might be some that don't work for us, okay? So a right scalene. Can I have a right scalene? So first of all, a right angle, you have exactly 90 degrees, exactly. So I know one of my angles has to be 90 degrees, okay? I'm gonna draw a triangle. Right scalene. Can I have a right scalene? It kind of seems like I can. Okay, right here would be my right angle. So there's the right angle. Maybe this one's, I don't know, 5. Okay, maybe this one is 7. That one seems a lot longer, right? And then maybe this one is, I don't know, 4. Okay, so it seems to me that it can be possible to have a right triangle that is scalene. So I am going to put another check right here. So I should have that so far. You see that? Okay. The next option is, can I have a right isosceles? Maybe. We'll check it out, right? Okay. Okay. Can I have a right isosceles? And you might be thinking, well, no, miss, you can't get it. But you know what? You're thinking about it wrong. Look at this. If I were to straighten it out like this, isn't that my right angle? Mm-hmm. It sure is. That's my right angle. And then these two lines represent my two that are the same. So we're pretending that they're 3 and 3, and the bottom one is 5. So can I have a right isosceles? I sure can. So I'm going to put another check mark here. Okay. The next one, we're still working with the right, but I need to see, can I have a right equilateral? Okay. So again, I need a triangle that has a right angle. Okay. So there's my right triangle. But it seems to me that this line right here is longer than the others. These two might possibly be the same, but this one is definitely going to be different. So is it possible to have a right triangle that is an equilateral triangle as well? I don't think so. So I'm personally just going to take a different marker, and where it says right and equilateral, I'm going to put an X. I cannot have a right equilateral triangle. Okay? Where all my sides are the same length. I cannot have that. Okay? All right. What's the next one? Obtuse. Obtuse. So can obtuse be scalene? Can obtuse be isosceles? And can obtuse be equilateral? All right. So can obtuse be scalene? Let's see. Let me do another sheet of paper. Can an obtuse triangle be scalene? Okay. All right. There's my obtuse triangle. There's my obtuse angle, nice and big. Okay. Can it be scalene where all the sides are different lengths? I think so. Maybe this one's 7. Maybe this one's 3. Maybe this one's 4, maybe. So 7, 3, and 4. I'm going to go with a yes. Yeah. So on this first one here, I'm going to put a check mark. Okay. On the next one, we have isosceles and obtuse. Okay, isosceles and obtuse. So again, I'm going to have that big angle. That big obtuse angle. Like that. And again, you don't have to be drawing out these triangles. We're just showing them. Okay. There's my big angle. So maybe pretend Miss Felt this is like a super good at drawing, okay? And that these two lines are equal to each other. So can I have an isosceles obtuse? Yes, I can. So let's pretend this one's 6, this one's 6, and this one's double that. That one's 12. So that's an isosceles obtuse. So it is possible to have an isosceles obtuse. So right here, I'm gonna put my other check mark. Okay, this is what I have so far. And then the last one is going to be an obtuse equilateral. Can I have an obtuse triangle that is equilateral? Okay. So again, I'm going to draw that big angle. Okay. So is it possible to have an obtuse equilateral? Doesn't look like it, right? You can have obtuse isosceles like we just said, but equilateral means that all your sides are going to be the same length. And there's no way that if I have a big angle like this, that I'm going to be able to make that the same length as the arms that are going this way. So the arm that's going across like this is not going to be the same length as the arms that are going like this. You're obtuse. So we cannot have an equilateral obtuse. So in that last bottom square, we're going to put an X. Okay? So that's one way of organizing our triangles or classifying our triangles as what they could be. We could have acute isosceles, we could have scalene right, and so on and so on. Okay, so sometimes you might want to refer to this, okay? There's one more thing I want to talk about, and you don't have to write this in, excuse me. You don't have to do this in your journal, I just want to show you, okay? Let's say I have an equilateral triangle where all my sides are 4, 4, and 4, right? That's what equilateral means. And then all my angles are the same. They're all going to be acute, okay? So let's pretend I have this. How would I classify this triangle? It's equilateral, right? Because all my sides are the same. Oops, equilateral. Okay, all sides are the same. My angles are less than 90, so we're going to call that acute. But this triangle also has one more name. And I'm going to say, and you might think, well, what are you talking about, miss? That's not the definition of that word. Yes, it is. Okay. The next one, it is actually also isosceles. Okay. This can also be classified as an isosceles triangle. And you're saying to yourself, miss, no, it can't be. Yes, it can. It's equilateral, it's acute, and it's isosceles. Because the definition of an isosceles triangle is actually a triangle with at least 2 of the same length of sides. So, 2 sides that are the same. So does this triangle have at least 2 sides that are the same? Yes, it does. 1, 2. Okay? Doesn't say it has to be exactly 2. If I put that in the notes in my other classes, I'm sorry, I take it back. But it can have 2 or more, we should say that. So for isosceles, so if we wrote down it was exactly 2, let's go back and change it to 2 or more congruent sides. Okay, and that's actually something I just learned myself. So just remember, there's things that I'm still learning when I go to my PLC meetings. I go and these other teachers, they teach me things. So even I make mistakes, and polygons are something that I've made mistakes on before. So I'm still learning myself sometimes, okay? So isosceles is 2 or more congruent sides. So this one is equilateral, it is acute, but it is also isosceles because at least 2 of my sides are the same length. Okay, so that is why. So just in case you ever run into that again, hint, hint, wink, wink, you know what I'm talking about? Okay, just be mindful that that is also the classification for that triangle. Okay, next up you should have this one. Okay, I'm only gonna do like 2 questions because I was reading over this, and this is like not that hard at all. Just be extra careful when you're picking your answer choices, okay? So I'm gonna focus right now on the first one, and it says which word correctly completes the chart below. So I just kind of amplified that onto this paper. You have your 2D figures, your what's that say? Polygons, a blank space, and then parallelograms. Basically, it means that whatever goes below it has to also be what's above it. So whatever I put here has to be a polygon and a 2D figure, but it also has to be a parallelogram. Your options are hexagon, quadrilateral, trapezoids, and triangles, okay? So first of all, we have the hexagon, which we know has 6 sides, okay? Then we have quadrilateral, which we know has 4 sides. The trapezoid is a special little guy. He's a quadrilateral, right? I just put quad for short, but not a parallelogram. And then we have triangles, which we know to be 3 sides, okay? So let's think about that. Let's focus here on that word parallelogram. We talked about parallelogram meaning 2 pairs of parallel sides. This is 1 pair, and then this is 1 pair. So we need to be mindful of that. It has to be something that can be a parallelogram. So looking at our answer choices, what did I just do with that page right here? Okay, it has to be something that has to have two pairs of parallel sides. So a hexagon. Does a hexagon have exactly two pairs of parallel sides? No, it has a bunch of lines. It has 6 lines, which means it'll probably have 3 pairs. So that is why a hexagon cannot be a parallelogram. Okay. The next option is quadrilaterals. Can quadrilaterals be parallelograms? Yes, they can. We talked about that in our hierarchy yesterday with our graphic organizer. Quadrilaterals are a type of, parallelograms are a type of quadrilateral. So that's a maybe. Okay. Can we have a trapezoid being a parallelogram? No, we can't. We talked about how a trapezoid only has 1 pair of parallel sides. It has to have, there we go. It has to have 2 pairs of parallel sides to be a parallelogram. A trapezoid only has these 2 lines here, but not the ones that are here. The ones that are here are actually going to meet. So we can't have a trapezoid. And then for obvious reasons, we can't have a triangle because it only has 3 sides. So that leaves us with, you guessed it, quadrilaterals with 4 sides. So right here would be quadrilaterals for number 1. Okay, that one's pretty simple. What other one did I want to talk about? I think I'm only going to talk about one more, to be honest, because I really didn't find, I was really, again, like I was saying, I was reading over this. It should not be hard. This one especially, we talked about that in our journals, in our notes about squares and rectangles. I'm sorry, rectangles and rhombuses, my bad. And number 3, which of the following could not describe the figure below? What could not describe the figure below? Can you see that one? Not. Okay, not describe it. Well, when I look at my angles, I know for sure these are acute. So sometimes I just put an A to show acute. Okay, so it's definitely acute. And by the looks of it, if I were to measure it, it seems like all the sides are going to be the same length. So I'm going to put a dash in each one. That one dash means that all 3 of those sides have the exact same length. And then we're left with isosceles triangle and then right triangle. Well, for right triangle, I know it has to have anything that's right, a right angle, it has to have that little square right there. So that also rules out D. So we're left with, that says that it could not be D. And then we just talked about how it could be an isosceles triangle. We just talked about that, how it could be an isosceles triangle because at least 2 of the sides are the same. So the only answer choice that's going to work there would be the right triangle because you have to have that little square to show that it's a right triangle. If it doesn't have it, it's not one. It's either got to be acute or obtuse. Okay, I'm going to leave it at that for these because like I said, these are super easy. Like I don't feel like you're going to struggle at all. And then you have a bit of review on the back here. The first one is the value. Remember, the value doesn't mean what place, it means how much is it worth. So if I were to pick out that one number that it's asking for, I need to put zeros behind it. That's the value of that number. Okay, number 2, describe the difference between gross income and net income. So I want the exact definition that I've given you or your teacher's giving you. Solve this one. When you're stacking your numbers, remember, when we're multiplying decimals, we are not worried about lining them up. We simply need to solve first, then move the decimal at the end. And don't forget about dropping that 0 when you're multiplying the second number. Don't forget about that. Okay. Number 4, primary composite for that number. How do you know? I want a sentence. How do you know? I know because. Okay. Don't just put I know. No. Okay. Number 5, solve 67 divided by 8. I think it comes out with a decimal, so you need to make sure that you give me a decimal number there. And then number 6, 1/3 plus 4/5. Some of us are still struggling with adding our fractions. Remember, if you get an improper fraction, you need to divide it. You need to give me a mixed number as your answer. A whole number with the fraction next to it if it becomes out as improper. Don't leave it as improper because I'm not going to count it right. Okay, and then double check to see if you can simplify it. Simplifying means to make your rainbows. See if you can divide it to make it smaller. We want to make these fractions as small as we can, okay? We don't like them to stay big, okay? If you have not finished this one, make sure you get that one done as well. It's not going to be homework, so just do your best. Remember, you do have some questions on the back. And then this last thing that I want to say is just for my first period class, because I made a mistake when I was teaching it to them. Number 4 says complete the sentence. A square is a rectangle. Okay, I told you before that a square is not a rectangle. I meant to say it opposite. And then the same thing for rhombus. A square is a rectangle, but, and then you do the opposite, okay? A square is a rhombus, but. So for my first period class, you need to go back and fix that in your journal where we did square, when we did rhombus and rectangle. So please go back and fix that. So again, we're going by what it says on this paper right here. A square is a rectangle, a square is a rhombus, and then complete the sentence, okay? If you do finish, put it in the basket. You need to be kind to the sub. You need to be on your best behavior. You're going to get double lunch attentions if he has to write down your name for any reason, okay? What else? If you owe popcorn money for the field trip, you need to tell your mom and dad that they need to pay as soon as possible because that money was due a long time ago. Okay, and if you still owe money just in general, like you need to pay off your trip, tell mom and dad to make a payment so that we know for sure that you're going on the trip. If your parents don't start making payments, we're not going to know. And I'm not going to know if I have enough money to take you. Scary, right? Okay, that should be it. So do your best today. If you finish everything that I mentioned, then you need to get on reflex or imagine, okay?